This object cost over $900 million to design and build. It took 10 years of engineering across 4 countries. And right now, it's sitting in a parking lot in Arizona because 6 weeks ago, NASA canceled the moon station entirely. But here's what nobody is talking about. They didn't abandon the moon. They canceled the space station because they've decided to do something far more ambitious. They want to build a base on the surface permanently, and the designs for that base already exist. The engineering documents are public, and when you actually read them, what NASA is planning to build on the lunar South Pole is unlike anything ever constructed in human history. This is a complete tour of the real NASA moon base, deck by deck. The plan, for the better part of a decade, was called Gateway, a small space station in lunar orbit, a waypoint, a pit stop between Earth and the moon's surface where astronauts could rest, refuel, and prepare for descent. It was going to be the ISS of deep space, built by NASA alongside the European Space Agency, the Japanese Space Agency JAXA, and the Canadian Space Agency. 4 countries, 1 shared outpost, orbiting the moon permanently. And it was real. The hardware existed. The first module, the Habitation and Logistics Outpost, or HALO, was physically built at a Northrop Grumman facility. The power and propulsion element was taking shape at Maxar Space Systems in California. Congress had poured hundreds of millions of dollars into it. Some estimates put the total Artemis program spend, of which Gateway was a centerpiece, at over $93 billion. And then on March 24, 2026, NASA Administrator Jared Isaacman stood at a press conference and said 11 words that ended the program. Gateway was dead. The orbital station canceled. The hardware repurposed where possible or simply shelved. But here's the part that should make you stop. NASA didn't give up on the moon. They gave up on orbiting it because the new goal is far more audacious. They want boots on the surface, and they want them to stay there. The last human beings to walk on the moon were Eugene Cernan and Harrison Schmitt. December 1972. They stayed for 75 hours. 53 years ago, every moon mission before and since has treated the lunar surface the same way. Get in, do the science, get out. No one has ever spent a night there without the protection of a spacecraft around them. No one has ever tried to live there. That is about to change, and the reason they've chosen the South Pole specifically is something most people don't know about. At the lunar South Pole, there are crater floors that have never seen sunlight in the history of the solar system. 4.5 billion years of total darkness, and inside those craters, water ice, billions of tons of it, confirmed by NASA's L-Cross mission when they fired a rocket into one of those craters and analyzed the debris cloud. That ice means water to drink, oxygen to breathe, hydrogen to burn as rocket fuel. The South Pole isn't just a location, it's a resource deposit. On the ridgelines above those craters, certain peaks receive sunlight for up to 6 months at a stretch. Continuous solar power, a natural advantage no other part of the moon offers. So this is where they're building. And what they're planning to build is a 3-deck pressurized habitat. The real schematics are sitting in a NASA technical report. We pulled them, and we're going to walk through every single section of it. We're going to start at the bottom, the system's core, and work our way up. Stay until deck 1, because the answer to what NASA has designed for the living quarters, specifically the sleeping pods, is something I genuinely did not expect when I read it, and I think you'll feel the same. Deck 3 is the base, the ground floor, and unlike every other part of this habitat, it is solid aluminum, a rigid pressure vessel, the non-negotiable structural core of the entire building. This is where everything that keeps 4 people alive on the moon lives, and the list is longer than you might think. The Environmental Control and Life Support System, ECLSS, handles air scrubbing, CO2 removal, water recycling, and atmospheric pressure. It is the same category of technology used on the International Space Station, where 93% of astronaut water is recycled. That includes sweat, that includes condensation, that includes, yes, urine. On the moon, there are no resupply ships coming every few months. The recycling efficiency has to be even higher. Power distribution, thermal regulation, and battery storage also live on Deck 3. The habitat will draw power from solar arrays on the ridgeline above, 50 kilowatts of electricity, and store it in batteries to survive the lunar night, which lasts 14 Earth days of total darkness. And then there is the airlock. Every EVA, every moonwalk begins and ends here. Astronauts suit up, the inner door seals, the air pressure drops to zero, the outer hatch opens, outside minus 130 degrees Celsius, vacuum, radiation. Inside that airlock door, the difference between alive and not. NASA's design spec requires the airlock to support a crew of 4, suiting up simultaneously, with enough rack space to inspect and repair EVA suits after every outing. On the moon's surface, a torn suit is not an inconvenience, it is a death sentence. The engineering around that one room is extensive. If Deck 3 is the body keeping the crew alive, Deck 2 is the mind, the reason the mission exists. According to the NASA reference design, this is where the science happens, and the scope of it is remarkable. Geology sample storage and processing, because the South Pole soil has never been touched. Regolith chemistry labs, remote experiment controls for surface instruments deployed kilometers away from the habitat, a communications hub managing data relay between the base, the orbiting Orion spacecraft, and Earth, 1.28 light seconds away. There's something NASA engineers reference when they design this level of the habitat, analogies to Antarctic research stations, specifically Concordia Station, the French-Italian base on the Antarctic plateau, 2 days of travel from any other human being. The isolation, the extreme cold, the need for total self-sufficiency, the psychological challenge of confinement. The moon base inherits all of those challenges and adds radiation, vacuum, and a surface gravity of 1/6 of Earth's to the list. But there is one detail about Deck 2 that you won't find in the press releases. The EVA Equipment Repair Station, it's listed in the technical documents as a critical functional space, meaning NASA expects suits, tools, and surface vehicles to break down regularly. They've designed an entire workshop into the base specifically to fix them. That's not pessimism. That's honest engineering. On the moon, everything that can break will break, and there is no calling for help. Here it is, the top of the habitat. And this is where the design gets unexpectedly human and also unexpectedly strange. Deck 1 sits inside the inflatable upper section of the habitat. Unlike the rigid aluminium base, this section expands after landing. Think of a rigid core that breathes outward to nearly double its diameter once deployed. It gives more interior volume without more launch mass. The same concept NASA has been testing with the Bigelow inflatable module attached to the ISS since 2016. Inside, you get 4 private sleeping quarters, a communal dining area, a fitness area. Because after a month in low gravity, bone density loss becomes a serious medical concern. And for the first time in any moon habitat concept, designs include provisions for a panoramic window module, a window looking out at the lunar surface, at the crater rims, at the Earth hanging in the black sky above the horizon, permanent, undeniable, there. But now, here's the part I mentioned at the beginning. The thing that stopped me when I was reading the engineering documents. Deck 1, the living quarters, is at the top of the habitat, which means it is the section of the building with the least shielding between the crew and the open lunar environment above them. On the moon, there is no magnetic field, no atmosphere. Cosmic radiation hits the surface directly. Particles from deep space that can penetrate standard habitat walls. The more material between you and the surface above, the safer you are. So NASA's designers put the sleeping quarters, the place where astronauts spend 8 hours completely stationary and unprotected, at the top. The thinnest point. Why? Because the answer to radiation isn't just shielding above you, it's shielding around you. The habitat sits partially buried in regolith, the lunar soil, which provides natural shielding on the sides and base, and the inflatable walls themselves will incorporate radiation-resistant materials and potentially filled water panels for additional protection. But there's a harder truth underneath it. There is no perfect solution to lunar radiation with current technology. Every person who lives in this habitat will receive a radiation dose higher than any human has experienced over an extended stay, except for the ISS crews in low Earth orbit, who still have partial magnetic field protection. The engineers know this. They've published it. They're building the habitat anyway because the alternative is to never go. And they've decided that never going is a worse outcome than going with acceptable risk. That is what makes this not just an engineering story, that is what makes it a human one. 6 weeks before NASA canceled Gateway, 4 astronauts, Reed Wiseman, Victor Glover, Christina Koch, and Jeremy Hansen, flew around the moon aboard Orion, the first humans to travel to lunar distance since 1972. They didn't land, but they looked out the window, and they saw what the base camp crew will see every day. NASA Administrator Isaacman said their observations are already shaping how the surface base is designed. Every detail that surprised them, every system that didn't perform as expected, feeds directly into the habitat engineering. Here is what I want you to take from this. The Gateway cancellation felt, to a lot of people, like a retreat, like giving up. It wasn't. It was a decision to skip the waypoint and go directly to the destination, to stop orbiting the moon and start living on it. Every toilet recycling system on Deck 3, every EVA repair bench on Deck 2, every sleeping pod on Deck 1 is a test run, a rehearsal, not for the moon, for Mars, where the journey takes 9 months, where there is no abort option, where you are further from help than any human being has ever been. The moon base isn't the end of the story. It's the first sentence. Before you go, I have one question I genuinely want to know the answer to. If you had to live in this habitat for 30 days, which deck would be the hardest for you? The system's core with no natural light, the science lab with no privacy, or Deck 1, the sleeping quarters, knowing what you now know about the radiation exposure? Drop your answer below. I'll be reading every single one. We're doing a part 2 on this, the pressurized rover that astronauts will drive across the lunar surface. It sleeps 2 people. It operates at minus 240 degrees Celsius. And the engineering decisions behind it are even stranger than anything in this video. Subscribe so you don't miss it. There's no algorithm guarantee you'll see it otherwise. If you want to understand why getting to the moon's surface is so much harder than people realize, the video on screen right now goes into the engineering of the Starship lunar lander. It's the vehicle that gets the crew from orbit to the habitat we just toured. Watch it. It makes this video make more sense. I'll see you there.